Volatile organic compounds, known as VOCs, are carbon-based chemicals that quietly escape into the air around us. Invisible and often odorless, they evaporate easily at room temperature, turning everyday materials into sources of airborne pollution. Widely used in modern life, VOCs play a hidden but powerful role in shaping the quality of the air we breathe. VOCs are released into the environment through human activities that often go unnoticed, like industrial waste dumped into rivers and lakes continues to release chemical vapors as contaminated water slowly breathes these pollutants into the air. Then, open burning of waste and agricultural residues sends clouds of VOCs skyward, spreading invisible toxins far beyond the flames. Even the simple act of spraying pesticides releases VOCs, allowing these chemicals to drift through the air and settle into soil, water, and the lungs of those nearby. Once released, VOCs persist silent, unseen, and widespread.
Chemical manufacturing plants often release volatile organic compounds from solvent used in production. One effective method to control this emission is activate carbon adsorption. Activated carbon adsorption works by capturing VOC molecules as contaminated air passed through a bed of activated carbon. Activated carbon has a highly porous structure with a large surface area, allowing it to attract and return organic compounds. As polluted air flows through the filter, VOC molecules adhere to the carbon surface while cleaning air is safely released back into the environment. In this case study, the effectiveness of activated carbon adsorption was evaluated by comparing VOC concentration before and after treatment. VOC levels were approximately 800 parts per million. After passing through the activated carbon system, concentration were reduced to around 100 parts per million. Overall, removal efficiency of nearly 19%, demonstrating the strong performance of this control method. These results show that activated carbon adsorption significantly reduces harmful emissions. By lowering VOC levels, the system improves air quality, protects worker health, minimizes environmental impact, helps industry comply with environmental regulation, and maintains safe working conditions. Activated carbon adsorption remains a practical and cost-effective solution for controlling VOC emission in chemical industry.
In automotive manufacturing, painting plays a vital role in both appearance and corrosion protection. However, behind the glossy finish lies an important environmental challenge. During automobile painting, especially in a spray painting operation, large amounts of volatile organic compounds are released into the air. These emissions mainly come from solvent-based paint, which are still widely used in automotive industry due to their durability and performance. Research shows that solvent-based paint contain various types of VOCs, including aromatic hydrocarbon, aldehyde hydrocarbon, ketone, as well as alcohol and other organic compounds. Once emitted, these substances contribute to air pollution and ozone formation, posing risks to both the environment and human health. Although water-based and powder paints were developed to reduce VOC emissions, they introduced technical challenges and other environmental trade-offs. As a result, fully replacing solvent-based paint remains difficult, making VOC emission control an essential priority. Several control technologies are used to manage these emissions. The most common method is adsorption using activated carbon, followed by thermal oxidation, which can remove up to 90 to 99% of VOC. Other approaches include adsorption biological treatment and spray with air recirculation, each with a different efficiency and cost. While VOC emission cannot be completely eliminated, effective control and technologies and sustainable practices play a vital role in protecting the environment.
In 2018, China consumed 15.5% of the world's coal. By 2019, most pollutants were under control, but one problem kept growing. which is tropospheric ozone, which rose by 6.5% across 337 cities in China. The main driver of this increase is volatile organic compound, which chemicals that form ozone and secondary organic aerosols. These studies focus on Shanxi province, a small region that used nearly 12% of China coal, to explore how coal burning contributes to this challenge. Research on VOCs from coal burning is still very limited. Most studies focus on vehicle exhaust, leaving coal-related emission poorly understood. Current data are inconsistent and lack standardized method. Scientists have shown that VOC emissions vary widely depending on the combustion technology and the coal origin. Without a detailed, localized database, it is difficult to accurately model and control photochemical smoke. Pollution control differs across sectors. Power plants use advanced systems such as selective catalytic reduction (SCR) to reduce nitrogen oxides, and wet limestone flue gas desulfurization to remove sulfur. Steel and coking plants rely on electrostatic precipitator and bag filter to capture dust. But in rural households, over 60 million stoves operate with low efficiency and no pollution control. These stoves release untreated emission directly into the air, creating a major gap in environmental protection. The chemical results are clear. In power plants and household stoves, butane is the dominant VOC. In cooking plants, benzene and styrene are most abundant. The study shows that alkenes drive ozone formation, contributing up to 87.6% of its potential, while aromatics account for more than 94% of secondary organic aerosol, which reduce visibility.
To summarize, volatile organic compounds (VOCs) are a major category of air pollutant emissions. Due to their high volatility, VOCs readily enter the atmosphere and contribute to adverse effects on human health, air quality, the environment, and overall ecosystem balance. Continuous exposure to certain VOCs can also result in serious health issues such as respiratory irritation and increased cancer risk. Here are some key recommendations in controlling VOCs emissions. First, industries should adopt effective emission control technologies such as activated carbon filters, thermal or catalytic oxidizers, and biofilters to capture and reduce VOC release. Second, using low VOC or VOC-free alternative in paints, solvents, and cleaning agents can significantly lower emission at the source. Next, regular monitoring and air quality assessment help ensure emissions remain within legal limits and prevent harmful exposure. Ensure the compliance with environmental regulations along with the adoption of cleaner and sustainable production practices supports a safer and healthier environment. Lastly, training and awareness program for workers on safe chemical handling and the importance of VOC control play a vital role in reducing emission effectively. By following these steps, industries and communities can work together to reduce VOC emissions, improve air quality as well as create a cleaner, safer and more sustainable environment for everyone.